Howdy, 8th grade. Today we're going to continue learning how to factor some trinomials. I'm going to start with a little bit of review, how we've been factoring in the past. Then we're going to do something a little bit different. We're going to use greatest common factors to look at some more complicated things and be able to factor those anyways. So we're going to start with review like we normally do. And just a real quick factoring example, what I want to do is going to be if we have x squared plus 5x plus 6. So if we're trying to factor this, I want us to remember that this last number is what we're going to try to multiply to. And we want to try to add to the middle number here, which is 5. So we're thinking, what two numbers add to 5 and multiply to 6? If we can't figure it out right away, I'd make a factor tree of my 6 here. Figure out I got a 3 and a 2. And so my possibilities would be either 3 times 2 or 6 times 1. 6 plus 1 is 7. I want a 5. 3 plus 2 is 5. That's what I want, so that's what I'm going to use. And then I can figure out that my factor would be x plus 3 times x plus 2. If I want to check this, I can always FOIL it, so I'll do that real quick. FOIL. My first is x times x, x squared. Outer is x times 2, which is 2x. Inner is 3 times x, which is 3x. And my last is 3 times 2, which is 6. I add all those up, and I get x squared plus 2x and 3x make 5x plus 6. And if we look, that matches what we started with. So this right here is our final answer, and we're good to go. But today we're going to look at something a little bit more complicated. Not too bad. We're going to be factoring things out before we can factor this way like we have in the past. So an example problem, because I know that sounds kind of weird, would be x to the 4th plus 5x cubed plus 6x squared. And looking at this, I know we got a little bit of a problem because that is not a 2, that is not a 1, and that, well, there's an x in the last term at all. So that is not what we're used to. But I'm going to say we're going to try to factor something out with the greatest common factor, like we have before we even started the whole trinomial thing, and then we'll take another look at it. So I'm going to start by making a factor tree of these. X to the 4th is just going to be x times x times x times x. 5x cubed is 5 and x cubed. X cubed is x times x times x. A whole bunch of x's here. And 6x squared is going to be 6x squared. 3 and a 2, and 2 more x's. Let me actually write an x there instead of a 2. There it goes. Alright, so if we're looking for the greatest common factor, we're just going to circle everything that these factor trees have in common. So I got 2 x's there, 2 x's here, and 2 x's in my last one. And that's the only one that all three of these have in common, are those 2 x's. So I'm going to take those out front. X times x, of course, is x squared. And then I'm going to put everything that I didn't take out back inside the parentheses. So I got my x squared here, plus 5x, plus 6. I drew that parenthesis a little far away. So I have x squared times x squared plus 5x plus 6. And just like that, I can factor this. We've actually looked at this one. So it would be x squared times x plus 2 times x plus 3. And just like that, we're done. So if we get any of these weird looking trinomials where you don't have the x squared, the x to the 1st, and the constant here, our first thing that we should try to do is to take out a greatest common factor and see if that works for us. So I want to look at a different one real quick, and then I'll give you guys a couple practice problems. We'll be all good to go. So this second one I want to look at is going to be 4x cubed minus 4x squared minus 80x. And one more time, this isn't quite what we're used to, but that is a-okay. So I'm going to do a factor tree of these. We get 4 times x cubed. 4 is 2 and 2, and x cubed is x times x times x. 4x squared, 4 and x squared. 2 xx. And 80x, I'm going to bring this factor tree over here. Gives me an 80 and an x. 80 goes to 8 and 10, 2 and 4, 2 and 2, 5 and 2, a whole bunch of 2's there. That's okay. And now I'm going to look for things that all of these have in common. So I see right off the bat that all of them have a 2. That's pretty easy. And actually all of them have a second 2. So I'm going to take that out too. And all of these have an x. But only the one. This last one only had one x, so I can only take one out. That's all right. It looks like what I have in common is 2 times 2 times x. 2 times 2 is 4, times x is 4x, times whatever's left. From this first term, I have an x squared plus, actually that's a minus, minus, only an x left here, and then plus 2 times 5 times 2, which is 20. Once again, I said the wrong thing. That is a minus. Both of these are minuses. This stays minus up top, or down below. So you have 4x times x squared minus x minus 20. So now the question is, once again, this right here is going to be the same as negative 1x. So if we're looking for a number, we need to be able to add to negative 1 and multiply to negative 20. So if it multiplies to a negative, that means I have one positive and one negative number. Ways I can get to 20. I'm going to write down all the factors of 20. I haven't shown you all this quite yet to make sure we get all the different options. To get to 20, 1 goes into 20. So it is 2, 4, 5, 10. And I think that's about it. So, well, 20 goes into 20. So it could be 1 times 20, 2 times 10, 4 times 5, 5 times 4, 10 times 2, or 20 times 1. And I'm going to say I need 1 to be negative, so let's just pretend that's the first one. So I should be able to find something here that adds to negative 1. So if I have negative 1 plus 20, that's negative 19, not what I want. Negative 2 plus 10 is negative 8. Negative 4 plus 5 is 1. Negative 5 plus 4, I'm sorry, these should be positive. There we go. Negative 5 plus 4 is negative 1. Negative 10 plus 2 is negative 8. Negative 20 plus 1 is negative 19. Looking back up here, I'm trying to add to negative 1, so it looks like my numbers are going to be negative 5 and 4. So I'm going to break that up. I end up with 4x, because I want to keep this. And I'm going to take my factored numbers, which are x minus 5 and x plus 4. And just like that, I am done. So I'm hoping this wasn't too much new stuff today. We've kind of looked at problems like this already. Just adding that quick little factoring out front, and we should be all good to go. Make sure you all do the lesson practice, and I will see y'all in class. Toodaloo.